Sums and products of zeros may be used to factorise polynomials. Let's have a look at an example involving a cubic polynomial. Factorise completely the cubic a of x equals 4x cubed plus 4x squared minus 5x minus 3. Now the coefficients of a of x are all integers, so we can test divisors of the constant term negative 3 to try and find integer zeros. And it just so happens that p of 1 is equal to 0, therefore one of the zeros is 1. We could have tested p of 3 or p of negative 1 or p of negative 3, and they could work as well, and we may get 0 there. But let's just stick with what we've just found. Now let the three zeros be alpha, beta, and 1. So this ordinarily would have been gamma, but we've found one of the zeros, so our third zero is 1. Now the sum of the zeros one at a time, that's negative b on a. So negative 4 divided by 4. So alpha plus beta plus 1 is equal to negative 1. Cleaning up this equation, so subtracting 1 from both sides, we have alpha plus beta is equal to negative 2. Let's call that equation number 1. Now the product of the zeros, so alpha times beta times 1 is equal to 3/4, so that's negative d on a. So that's negative 3, so it becomes positive 3 divided by 4. So therefore alpha times beta, or alpha beta, is equal to 3/4. And let's call that equation number 2. So solving equations 1 and 2 simultaneously, okay, and I didn't show that there, but alpha is equal to negative half and beta is equal to negative 3 on 2. So if you substitute those two values into equations 1 and 2, you'll see that it'll work. Now a of x can now be expressed in terms of the product of the three zeros. So a of x is equal to x minus 1 in brackets multiplied by x plus half in brackets multiplied by x plus 3 on 2. But we have a slight problem with this in that the original cubic is non-monic. The leading coefficient is 4. So what we do is, if you look at the bracket in the middle, it's x plus half. So we're sort of going to eliminate the fraction here by multiplying this bracket by 2. And for the third bracket, if we multiply this one by 2, that'll eliminate the fraction here, this 3 on 2. And what we end up with is a of x is equal to x minus 1 in brackets multiplied by 2x plus 1 multiplied by 2x plus 3 in brackets. And this is the non-monic expression that is the factorized version of a of x. And if you multiply that out, and if you looked at the leading term, so x times 2x, you'll get 4x cubed, of course. And negative 1 times positive 3 will give us the constant term of the original polynomial.